7, we're asked to do a couple things here. We need to first find the derivative of this function, and then we need to find where the function has horizontal and vertical tangent lines. So first, let's think about how we're going to tackle the derivative here. This function is a product of two different things, 3x squared and cube root of 4 minus x squared. And it's not really simplifiable in any way, so we're just going to have to use the product rule to find this derivative. So remember that the product rule, to apply the product rule, you just do the derivative of one piece times the other piece, and then switch those and add them together. So for example, the first term could be the derivative of 3x squared is 6x times the other piece, which I'm going to write as a fractional power, 4 minus x squared to the 1/3. So then we add the other combination, where we just have the first piece times the derivative of the second. So we have 3x squared times the derivative of 4 minus x squared to the 1/3. So to do this derivative, we're going to have to use the chain rule. So the outermost thing that's going on here is the 1/3 power. So we're going to bring that down. I'll write this down here so I don't run out of space. 1/3 4 minus x squared. And the new power would be that power lowered by 1, which is negative 2/3. But then because of the chain rule, we have to also multiply by the inside. So the derivative of the inside. So the derivative of 4 minus x squared is negative 2x. So that's our total derivative, and now let's try to write that as simply as possible. We can do a little bit of simplification and canceling in the second term. So the first term is already about as simple as it can get. So in the second term, we have this 3 and 1/3 that would be canceling out. Also, we have x squared times negative 2x, which would give us negative 2x cubed. So it's going to switch us to a minus there. Negative 2x cubed times our other term is 4 minus x squared to the negative 2/3. So our goal here is to figure out where are the horizontal and vertical tangents. But in order to figure that out, we need to simplify this into a fraction if possible. And you know that this one is going to simplify that way because we have a negative power here, which tells us that we're going to have a denominator. So what we can do to essentially get this down into a denominator, it would be equivalent to saying, let's just take this whole thing and multiply by 4 minus x squared to the 2/3 on top and bottom. Bottom being, like, let's say we have a 1 down here. The reason I want to do that is that's the same thing as moving this negative power to the bottom and doing a common denominator, kind of all in the same step. So it'll get rid of this term, and we will have it now on the denominator, but it will also help us simplify the first term. So if we multiply this 4 minus x squared to the 2/3 times top and bottom, our first term here would be 6x times, now we have 4 minus x squared to the 1/3, and we're multiplying by 4 minus x squared to the 2/3. So we would just add those powers, and they would become 1, so we just get 4 minus x squared. On the second term, 4 minus x squared to the negative 2/3 and 4 minus x squared to the 2/3 multiplied together to become 1, so we just have minus 2x cubed. And our denominator now is 4 minus x squared to the 2/3. So you can see this did a lot of simplification for us in one step. Next, our numerator could be expanded here. I'll just rewrite the numerator to then write it in the next step. This would be 24x minus 6x cubed if we distributed the 6x across, minus 2x cubed. So you can see there we would get 24x minus 8x cubed if we combined the x cubed terms. And then furthermore, we could factor out an 8x because both of these have an x in common, both of them have an 8 in common. So we can write this in one more simplified step as 8x times 3 minus x squared. That's by factoring the 8x out of what our numerator was simplified to. And we still have our denominator of 4 minus x squared to the 2/3. So this is as simplified as our derivative can get. Nothing else can cancel here. Nothing else can be factored. So now the second part of our question is, where are the horizontal tangents and where are the vertical tangents? So the horizontal tangents are going to occur wherever your derivative is equal to 0. Since we have a fraction, the derivative equaling 0 is the same thing as just the numerator of that fraction equaling 0. So wherever the numerator is equal to 0, we'll have horizontal tangents. So let's figure out where those would be. This is already factored for us, so that should be pretty simple. The numerator would be 0 either when x is equal to 0 or when 3 minus x squared is equal to 0. So that would be x equals 0 or plus or minus the square root of 3 to make this second term equal to 0. So those will be horizontal tangents. So we end up with vertical tangents on a function wherever our derivative is undefined. So in this case, since we have a fraction, it's very easy for us. Where is our denominator going to be 0? So if we set the denominator equal to 0, then we have the x values where our function would have vertical tangent lines. So where is this going to be 0? Well, we have 4 minus x squared to the 2/3 power. So when our base is 0, we're going to be 0. So where is 4 minus x squared equal to 0? That's when x is equal to plus or minus 2. And those would be our vertical tangents. So our horizontal tangents is whatever makes the numerator 0. Our vertical tangents are whatever make the denominator equal to 0. So we have 3 horizontal tangents, 0, plus root 3, and minus root 3. And we have 2 vertical tangents, 2 and negative 2.
The Teaching Center, UF's Learning Resource Center.